Hey, before we get started, I want to point out something about Apex that's a little weird. They list the first and second fundamental theorems of calculus backwards. So the first fundamental theorem of calculus is the integral of a closed interval is you can evaluate it by subtracting the antiderivatives. And the second fundamental theorem of calculus is that if you take the derivative of an integral on an open interval, so from some number to x, then you take the derivative of that, and it's just the function f of x. So they just do those backwards. Kind of weird. And so this might kind of look like what they call the first fundamental theorem, which is really the second fundamental theorem, but it's really not, because this is a closed interval from -3 to 1. So if you think about the actual first fundamental theorem of calculus applied to just the integral part, that's going to tell you you're going to get some antiderivative of this function and call it big F, or whatever you want to call it, and then it's going to be big F of 1 minus big F of -3, and that's going to equal some number, some constant number that's not going to change, because that's going to represent the area under the curve, right? The area under this curve. Well, what happens when you take the derivative of a constant? The derivative of any constant is 0. So this one is a trick question. It's none of the above. And if you think about it, I mean, this is obviously poo, because you didn't take an antiderivative. And, well, the deal is, this is like a trick to see if you're going to try to use the actual second fundamental theorem of calculus and treat this thing like it's x, but it's really not, it's 1. And then even if you did that, this should be x, right? So if it was the derivative of -3 to x of 2t cubed plus 3 dt, then it would be 2x cubed plus 3.